Have you ever wondered why, in an age of instant digital everything, some blockchain transactions can feel as slow as sending a letter by mail? This question isn't just a minor inconvenience. It strikes at the very heart of what will determine the future of decentralized technology. For blockchains to truly revolutionize industries like finance, gaming, global communication, they must be able to handle a massive volume of activity without buckling under pressure. Early pioneers like Bitcoin and Ethereum laid a crucial foundation, proving that secure, decentralized networks were possible. However, their designs often resulted in a trade-off. In exchange for robust security, they sacrificed speed and created high transaction costs, especially during periods of peak demand when the network becomes congested. This limitation is often referred to as the blockchain trilemma, a concept that suggests a blockchain can only optimize for 2 out of 3 fundamental properties: decentralization, security, scalability. Achieving all 3 simultaneously has been the holy grail for developers and engineers for over a decade. Imagine a highway designed to be incredibly secure and open to anyone, but with only a single lane. During rush hour, traffic would grind to a halt, and the only way to get through faster would be to pay an exorbitant toll. This project, known as Solana, was built with a singular focus on performance, scalability, and low costs, positioning itself as a platform capable of handling the demands of global-scale adoption. Its unique architecture and innovative solutions have made it a major player in the ongoing evolution of blockchain technology, warranting a closer, fact-based examination. Solana emerged from this competitive environment with a clear and ambitious mission: to build a blockchain for the world. Launched in 2020 by Anatoly Yakovenko, a former engineer from Qualcomm, Solana was designed from its very inception to overcome the scalability bottlenecks that plagued its predecessors. The core idea was to create a high-performance Layer 1 blockchain, meaning it wouldn't need to rely on secondary Layer 2 networks to process transactions quickly. Instead, its fundamental architecture was engineered to be exceptionally fast and efficient on its own. This approach aims to provide a seamless experience for both developers and users, with the promise of processing tens of thousands of transactions per second for a fraction of a cent. The problem Solana directly addresses is the inability of older blockchains to keep pace with real-world demand. For decentralized applications, or dApps, to compete with their centralized counterparts, they need to operate at a similar speed and scale as Visa or the New York Stock Exchange. Solana's brand positioning revolves around this very concept, often called one of the fastest blockchains in existence. It sells itself as a robust infrastructure platform for developers looking to build scalable dApps. Decentralized finance, NFTs, Web3 gaming, global payment systems. The native cryptocurrency of the network, SOL, serves multiple functions: paying for transaction fees, securing the network through staking, allowing holders to participate in governance. Behind this mission is Solana Labs, the primary organization guiding development, headquartered in San Francisco. However, Solana itself is an open-source project. Developers, validators, users. This decentralized community is fundamental to Solana's long-term vision. By providing an open platform, permissionless access, and high-performance infrastructure, Solana aims to empower builders to create applications that were previously not feasible on a blockchain. Imagine trying to build a global, decentralized social media platform where every like, every post, and every comment is a transaction. At the core of Solana's impressive performance is a groundbreaking innovation known as Proof of History, or POH. To understand why this is special, let's first look at how other blockchains work. Most networks rely on validators to bundle transactions into a block, and then communicate with one another to agree on the order. That consensus process is time-consuming. Lots of back-and-forth messaging. Think of it like a group of people trying to agree on the exact sequence of events. They have to talk, compare notes, and vote until there's one agreed version. That communication overhead creates latency. Solana's Proof of History changes the game. It creates a verifiable, chronological record of events before consensus. Visualize a clock taking a cryptographic snapshot every fraction of a second. Each transaction is time-stamped with one of those snapshots. Because timestamps are cryptographically linked in a continuous chain, anyone can independently verify how much time passed between 2 events. That gives the network a trustless source of time. Validators don't need to waste time negotiating order. They can read POH timestamps and know the sequence instantly. That enables parallel processing. Traditional blockchains are like a single-file checkout line, one customer at a time. Solana is like a supermarket with dozens of checkouts running simultaneously. The manager, the consensus mechanism, doesn't have to tell each cashier when to serve. Cashiers simply look at the line and process customers because the order is self-evident. Parallel processing is a core reason Solana reaches high throughput. Important. POH is not a consensus mechanism itself, it's a component that works with a consensus mechanism, in Solana's case, proof of stake. A powerful blockchain is only as valuable as the applications and communities built upon it. As of 2025, the Solana ecosystem has blossomed into a diverse and vibrant landscape, attracting developers and users drawn to its high speed and low transaction fees. One of the most prominent sectors is decentralized finance, or DeFi, where Solana's performance capabilities are on full display. Platforms like Jupiter, a liquidity aggregator, and Marinade Finance, a liquid staking protocol, allow users to trade, lend, and earn yield on their assets with a speed that rivals traditional financial services. The ability to execute complex trades almost instantly for pennies has made Solana a preferred venue for on-chain traders and DeFi power users who find other networks prohibitively slow and expensive. The world of digital collectibles and gaming has also found a natural home on Solana. The low cost of minting and trading non-fungible tokens, or NFTs, has fostered a thriving art and creator economy. Marketplaces like Magic Eden became household names by offering a seamless user experience where buying, selling, and discovering new NFT collections happens in seconds, not minutes. Beyond static images, the Solana gaming sector is rapidly expanding. Projects are developing fully on-chain games where every action from acquiring an item to winning a battle is a verifiable transaction on the blockchain. This level of integration is only possible on a network that can handle thousands of microtransactions per second without incurring high fees for players. Another rapidly growing area is the development of decentralized physical infrastructure networks, or DePIN. These projects use blockchain incentives to build and operate real-world infrastructure, such as wireless networks, sensor arrays, or energy grids. Helium, which migrated to Solana, is a prime example, creating a decentralized wireless network powered by user-operated hotspots. Hivemapper is another, building a decentralized global map by rewarding contributors who collect street-level imagery with dash cams. These ambitious projects require a blockchain that can process a massive volume of small data transactions from millions of devices globally, a task for which Solana's architecture is uniquely suited. When discussing high-performance blockchains, the comparison to Ethereum is inevitable. As the pioneer of smart contracts, Ethereum established itself as the dominant platform for dApps, boasting the largest ecosystem and the most battle-tested security. However, its success also highlighted its scalability limitations. In its original proof-of-work form, and even after its transition to proof-of-stake, Ethereum's mainnet has been constrained to around 15 to 30 transactions per second. This low throughput leads to network congestion and extremely high gas fees during peak usage, making many applications economically unviable. Ethereum's solution to this has been a roll-up-centric roadmap, relying on Layer 2 scaling solutions to handle the bulk of transactions off-chain. Solana takes a fundamentally different approach. Instead of offloading activity to Layer 2s, it is designed as a monolithic or integrated blockchain. Its goal is to achieve massive scale on the base layer itself. This is where the technical differences become stark. While Ethereum struggles with 15 to 30 transactions per second on its mainnet, Solana has a theoretical maximum of over 65,000 transactions per second, and consistently demonstrates several thousand transactions per second in real-world usage. Similarly, transaction costs are worlds apart. An Ethereum transaction can cost anywhere from a few dollars to over $100, whereas a Solana transaction typically costs a fraction of a cent. This makes Solana far more suitable for high-frequency applications like micropayments, on-chain order books, interactive gaming. This architectural divergence presents a clear trade-off. Ethereum's strategy creates a fragmented ecosystem where users and liquidity are spread across multiple Layer 2 networks: Arbitrum, Optimism, Polygon, which can create complexity when moving assets between them. Solana's integrated approach provides a more unified and seamless user experience. All applications exist on one fast layer, making them easily composable. The trade-off, according to critics, is potentially greater hardware requirements for running a validator node, which could impact decentralization over the long term. Ultimately, the better blockchain depends entirely on the specific use case and philosophical priorities. As with any popular technology, Solana has been the subject of several myths and misconceptions. One common critique: network stability. Detractors point to past outages. Fact: Solana experienced degraded performance and halts, especially in earlier years. These incidents were largely caused by novel bugs and unprecedented levels of transaction spam overwhelming the network. Developers have relentlessly worked to address these issues. Quick, stake-weighted quality of service, fee markets, Firedancer validator client, upcoming to further enhance stability and performance. Another persistent myth: Solana is centralized and controlled by insiders. The concern often stems from higher hardware requirements for validators. But decentralization can be measured by other metrics. The Nakamoto coefficient has been steadily increasing. Hundreds of independent validators operate today, across dozens of countries. Misconception: speed sacrifices security. Solana's security uses the same cryptographic principles as other major blockchains. The security of a proof-of-stake network depends on the value staked. Billions of dollars of SOL are staked. Attacking would be prohibitively expensive. Proof of history doesn't reduce security, it streamlines transaction ordering. Transactions are then validated by proof-of-stake consensus. Finally, myth that low fees are unsustainable. Solana's fee model is built for volume. Thousands of transactions per second mean validators still collect substantial total fees. High volume, low margin keeps costs low and incentives intact. This deep dive has provided a factual overview of the Solana blockchain from its core technology to its thriving ecosystem in 2025. We explored proof of history, types of applications on the platform, how Solana compares to Ethereum, and we addressed common myths with verifiable facts. The goal: a foundational understanding, no hype. Blockchain evolves fast. Keep learning from reliable, official sources. Get information directly from teams and communities building the tech. Start at solana.com, documentation, developer resources, ecosystem overview. Visit the Solana Foundation site for mission, governance, community initiatives. Use block explorers, Solscan, Solana Explorer to check transactions, check validators, check network performance. Follow official Solana accounts on X for upgrades and ecosystem news. Approach crypto with caution. The community is vibrant, but misinformation spreads fast. Be wary of unsolicited advice, especially on social. Be skeptical of anyone promising guaranteed financial returns. Double-check URLs to avoid phishing. Never share your wallet's private keys or seed phrases. These resources are safe starting points for your educational journey. Engage in official forums and developer discussions. Always verify from multiple trusted sources. Solana is a significant, innovative force in blockchain focused on a single high-performance layer, enabled new classes of dApps, attracted a large community of builders and users. This is educational only, not financial advice. Decide to use, build on, or invest based on your own research and risk assessment. Learning is a marathon, not a sprint. Keep studying and stay curious.